Alright, in this video we're going to find the center and radius of a circle. So start with example 3, picking up from where we left off. Finding the center and radius of x plus 2 in parentheses squared plus y minus 1 in parentheses squared equals 4. So much like the notes in parabolas, we have x minus h in parentheses squared and y minus k in parentheses squared. So whatever's after the x, we're going to take its opposite, that'll be our value of h. Whatever's after the y, we'll take its opposite, that'll be the value of k. In this case, h is going to equal negative 2 and k is going to equal 1. And for the right hand side, we'll have r squared equals 4, and that's going to make r equals 2. Remember, when square rooting both sides, we usually think of the positive and negative roots, but because the radius is a distance, we only consider the positive square root of 4, not the negative square root of 4. Positive are the principal's roots. So we have the center of the circle at negative 2, 1, and the radius is 2. Now, we can use some of the techniques that we learned in the parabolas, in particular finding the vertices of parabolas, to find the center and the radius of a circle that is not in standard form. This video is going to introduce things a little bit differently than a lot of other teachers and professors will. The way I do it is different from how a lot of other people do it, and the other way that I'm not going to use, the other way, more popular way, is called completing the square. So if you're looking at how to do this the other way, it's a technique known as completing the square. So it's pretty much a process of getting all the constants onto one side of the equation. So we'll have all of our variables on one side, our x squared and y squared and x and y terms on the left, and we'll move our constants without variables on the right. And then we're going to find the x coordinates of the vertices of the x and the y terms. And those are going to be the values of h and k respectively. And it'll make a little bit more sense of what this means when we actually go through and do a couple examples. So don't fret if you don't understand what this means just at the moment. Hopefully we'll take care of that. The x's as the we're going to use the x's as the variable when finding the vertex for y's parabola. So what that means is if we have something like 2y squared minus 7y, rather than enter that into our calculator and find the vertex as it is, 2y squared minus 7y, we're going to instead use 2x squared minus 7x. The reason being is when you switch your x's and y's from graphing parabolas, you also switch your h and k coordinates of your vertex. So you'll see that as we do these examples, for finding the vertex of the y terms for that parabola, we're going to type them into the calculator with x's instead. And then the y coordinates of the vertices that we get, we're going to add the absolute value of those y coordinates to the right hand side that has the constant on it. So this is a pretty wordy process, and I can understand if it doesn't make a whole lot of sense, but hopefully after seeing it in action, you'll get the hang of it. So let's try a couple examples. So example 4a, we have find the center and radius for 3x squared minus 6x plus 3y squared plus 4y minus 4 equals 0. So the first step was to take this constant of minus 4 and move it over to the right hand side by adding it. So we have 3x squared minus 6x plus 3y squared plus 4y equals 4. So just moving that minus 4 over to the right. Now I color coded these in red and blue. Hopefully the blue is easy to see on the screen. Just to separate them and kind of treat them one at a time. So starting with the 3x squared minus 6x, if we graph that, let's say in our graphing calculator, we'll get a vertex of 1, negative 3. So this x coordinate of 1 for the vertex, when we go to write our equation of our circle, it's going to be the h in the x minus h squared. In blue, rather than graphing 3y squared plus 4y, instead graph 3x squared plus 4x. So that's what I meant when I said about using x's for the y variable when graphing the parabola involving the y term. So instead of graphing 3y squared plus 4y, graph 3x squared plus 4x, and that vertex is at negative 2/3, negative 4/3. So negative 2/3 is going to be the value of k in our equation. So we have, out in front, we have 3 times x minus h is going to be x minus 1 in parentheses squared, plus, out in front of y squared, we have a 3, so 3 times y minus negative 2/3 becomes y plus 2/3 squared. It equals 4. And then over here on the right is where I mentioned earlier about adding the absolute values of the y coordinates of the vertices. So let's go back and see what the heck I'm talking about there. The y coordinate of this vertex is negative 3. The y coordinate of this vertex in blue is negative 4/3. We're going to add the absolute values of those to this 4 on the right hand side. So 4 plus the absolute value of negative 3 plus the absolute value of negative 4/3, which remember is just going to drop your negative signs. So when we simplify the right hand side, we get 25/3. Now, in the equation of a circle, we don't have anything in front of the x minus h in parentheses squared, and we also don't have anything in front of the y minus k in parentheses squared. So what we need to do next, and this is going to repeat itself a little bit like this in the section on ellipses, we're going to divide both sides, everything on both sides, by 3, by whatever's in front of these parentheses. And with circles, for the equations of circles, these two coefficients in front of the parentheses should be the same number. So dividing everything by 3, we'll get x minus 1 in parentheses squared plus y plus 2/3 in parentheses squared equals 25/3 divided by 3 is the same as 25/3 times 1/3. And 25/3 times 1/3 multiply across, we get 25/9. So this is our standard equal 25/9. So take the square root of 25/9, which just means take the square root of the numerator and the square root of the denominator, and we get 5/3. So our center is at 1, negative 2/3. Our radius is at 5/3. Example 4b, we have 2x squared plus 5x plus 2y squared minus 8y plus 1 equals 0. First step, we'll subtract this 1 from both sides. And we're going to graph in first 2x squared plus 5x. I have that in red for color coding. And then 2y squared minus 8y, but we're not going to graph them with y's. We're going to graph it as 2x squared minus 8x. So our h's and k's don't get flip-flopped in finding that vertex. So in red, the vertex for 2x squared plus 5x is negative 5/4 and negative 25/8. In blue, the vertex is a lot friendlier, is at 2, negative 8. So we're going to have 2 parenthesis x minus negative 5/4 squared plus 2 parenthesis y minus 2 squared is going to equal negative 1 plus the absolute value of negative 25/8 plus the absolute value of negative 8. So 2 times in parentheses x plus 5/2 squared plus 2 times in parentheses y minus 2 squared equals negative 1 plus the absolute value of negative 25/8 plus the absolute value of negative 8. Simplifying the right hand side, we get 81/8, and here we got to divide everything on both sides by 2 or multiply both sides by a half. When we do that, we get x plus 5/4 squared plus y minus 2 squared equals 81/16, 81/8 times 1/2. And that's going to make our center negative 5/4 and 2. Our radius is going to be the square root of 81/16, which is 9/4. All right, that about does it for this video, and